signed numbers, this is useful like when we are representing a negative number, we can use signed numbers to represent them. How does the signed number look like? For example, if you have a 4-bit machine like this, or let's say 5 bits machine like this, we use one of the bit for the sign. So this one is sign, and in the sign numbers, if the value here is 0, that's a positive number. If the value here is 1, that is negative number. Okay, that is the sign number, and the maximum number it can hold is 15. So it can be negative 15 or positive 15 based on the value we are having in the front. Okay, so let's see how we can write the positive 10. To write the positive 10, what do you do? You put a 0 in front because it's positive, and we know that in binary the first digit contains the weight of 2 power 0, second digit contains the weight of 2 power 1, third digit contains the weight of 2 power 2, and the fourth digit contains the weight of 2 power 3. So if we add 8 and 2, that gives us 10, right? 8 and 2. So this is going to be 1 0 1 0. So this is going to be 1 0 1 0 right here. This is actually positive 10. And if you want to write a negative number, let's say negative 13, you can represent that one in sign number like this. To get 13, you have to have 8 plus 4. This should be 1 1 0 0. So we are going to have, for the negative, we put a 1 in front, and then 1 1 0 0. Okay, let's look at 3 digits, like a 4-bit binary number, 4-bit sign number. So in 4-bit sign number, in one bit we are going to use sign here, and we are just going to use 3 bits for the numbers. So the maximum number we can have is 7. If it's more than that, we are going to have a problem. So here, like for example, if I add 5 plus 3, I'm going to have a problem because we don't have enough space for it, because the maximum number in a 3-bit is 7. So 8 cannot fix it, I mean fit here. And if you have the same, like -5 -3, that's going to give us -8, and it cannot fit here as well. So in sign number, like if you do the addition of like same same signs in front, like positive positive, negative negative, we are going to have a problem. But if it's opposite, we can add them, like positive 5 minus 3, that's going to give us 2, and then positive 3 minus 5, that's going to give us -2. 2 plus 3, that's 5. So you can see, like if we have opposite sign, it's easy to add, but if we have same signs, we are going to have a problem. So that's why this is not desirable, because this is taking up space. The sign is taking up one bit that can be used for something else. Like if we don't use this sign here, then the maximum number we can have is 15. We are limiting it because of we are using this bit right here. So for this one, to avoid this problem, what we do is we use 2's complement. Now let's see how we can use 2's complement. Let's look at an example of 2's complement. Let's say I want to write -7. So in 2's complement, what we do, there's an equation for 2's complement, 2 power n, and then minus the number. N is the number of bits, and the number is whatever the number we are trying to write. So here, let's say I'm taking 4 bits to write the 2's complement. So I'm gonna put 2 power 4 here, and since I want to write the -7, I have to find the absolute value of -7, that is 7. So I plug it in this equation, 2 power 4 minus 7. That should be 16 minus 7. That's equivalent to 9. Okay. And if you write 9 in binary, we know that 9 is 8 plus 1. So 8 is we know that fourth digit of the binary number carries the weight of 8. So we are going to have 1 right here. And then 1 is in the first digit. So this is basically 1001. Now nobody does 2's complement in this way because you have to actually remember this equation. Nobody actually remember this, and it's because there's an easier way to do it. How you can do it easily? Let's look at the second method to find the 2's complement. The 2's complement of -7. Complement of -7. To find the 2's complement, what you do is the first step is you find the ones you write the 7. 7 in binary representation is 0 1 1 1, and then you find the ones complement. Ones complement is basically flip. Like if you flip ones with zeros and zeros with 1, that's going to be ones complement. Now let's go ahead and write the ones complement. So this one, if you flip this one, this is going to be 1 0 0 0, and if we add 1 to that, that's going to be the 2's complement. So the third step is add 1 to step 2, and if you do it, you're going to get the 2's complement. That is 1 0 0 1, and you can see we get the same answer here as well, and this one is much easier. And that's it for this video, guys. I'm going to go ahead and continue with my next video. See you guys on my next video, and don't forget to subscribe my channel. See you guys later.